Hey, thanks so much for coming out. This talk is Securing Without Slowing. This talk is on DevOps. Hi, I'm Wolf. And a lot of times when I've been in organizations recently in DevOps, it all sort of starts the same way. We got a happy CIO and he's building stuff, and we got a CISO who's doing the good work of CISOing and securing the product, and we got a dev team who's doing some cool stuff. And they hire in a whole bunch of other folks. And the CISO's like, yeah, I've got an AppSec program around this. I've got change management around this. I've got folks doing the right thing. I've got it under control. And of course, all those controls add friction. All those controls slow things down. So at some point in time, they're like, hey, let's do DevOps. And they start building up some momentum. They have a skunkworks project. They're working on something small, something cool, and doesn't necessarily get back to the CISO until it does, right? Until someone's like, hey, do you know that we're doing DevOps? Do you know that they're doing stuff outside the change control windows? Do you know they're not following the processes? And someone freaks out, and then I get a call, and it's an AppSec guy going, have you ever heard of this DevOps thing? They've got it, and I don't know what it is, and they're telling me they don't need change management because it doesn't change, don't worry. And so a lot of this talk is reflective of some of the controls we've been putting in place in these scenarios. One of the things that I've talked about for some time now is I go to dev conferences, I go to security conferences, and there's this, seems to be this 2-year cycle. I'll hear about something like 2 years ago the developers are all fired up about, they're all excited about it. DevOps, Dockers was another one. I was like, this is great, it's the greatest thing ever, we're gonna build all this cool stuff and it's gonna be fantastic. And the clock starts ticking, right? And people start building cool stuff, they start implementing the technology, they start adopting it, and it gets mainstream and it hits everything. And right about there is where security hears about it, and then we hear about the security conferences. That's when people are freaked out, that's when they're panicking, that's when they're like, oh my God, do you know what's going on? Usually it takes about 2 years. Recently, I think we've been getting a little bit better at this. Did anyone see the Kubernetes talk yesterday? Yeah, I recognize a couple of you guys in there. That was awesome. I'm like, yes, because here's like, developers are like, Kubernetes is great. And hackers are like, it sucks. And we're like within weeks of each other, which is fantastic. So we're getting a little bit better. But we usually have this lag, and this lag is what introduces a lot of risk. And then, of course, you try and bolt on security. So this talk will go through that, right? So imagine, if you will, that you've got DevOps. DevOps is very simple to secure. There's just a few things you need to do. You need to do a design review. You need to do code review. Do a code inventory, know where all your lines of code are. Do an asset inventory, know what your assets are and when they're spinning up and when they're getting removed. Do static analysis of your code. Do dynamic analysis of your environments. Do interactive analysis, and also don't forget to vol and scan all your systems. Make sure you know what all your software composition is. Do change monitoring, file integrity monitoring in case anything changes on the file level that was missed by change detection, which was missed by SAS and everything else. Infrastructure vulnerability management, struts and everything that may be best there. Add in real-time application protection, put a WAF in front of it, and then do a pen test. That's it. Thanks for coming. I hope everyone got that. I can scroll back if you want to take a screenshot. That's all you got to do, folks. So, needless to say, when I first sit down with a lot of DevOps teams, and they're like, what do I need to do? And it's this. They're like, do we really need to tell security? I mean, how much do they really know? Just tell them it's out of scope. So when we start looking at DevOps and figuring out where these things come together, it's important, I believe, to start with some fundamentals, some 101 on what DevOps is. And so when we walk through this talk today, I'm going to explain how DevOps works. I'm going to explain the DevOps pipeline. And then I'll tie a lot of those controls into the pipeline where they go. The pipeline looks something like this. You know, we all know the dev cycle. You code, you build, you test, you package. It's the release, the configure, and the monitoring, that automation that we've got from build on down that really separates DevOps from traditional development. Because with traditional development, you're doing a lot of the same processes, but it's a very manual process. Very long cycles, very drawn out. And of course, on top of those processes, we've got a whole bunch of new tools for doing the continuous integration and continuous development where you're building these things together. So I'm going to talk through how it all works, and then we'll apply the security controls. Because I do a lot of consulting, I should note that any story that I tell in this is not indicative of any friends, anyone in the community, anyone in the industry, any clients. We're going to reference a made-up company called Sitting Duck Shipping who's doing DevOps, and we'll use them as a case study. So these are all rooted in real things that I've went through, but like any good story is not really like the true story, right? If you're watching on screen, this isn't about you, it's about them. So Sitting Duck Shipping has decided to do DevOps, and they decided to add security. And so oftentimes when we security folks get pulled in to add security, we're like, this is fine, we've got this. We're going to secure it like a castle. That's how we're taught. It's every single book ever. I always scratch my head at that because I haven't seen many castles in real life recently. But it's a thing. So we're going to secure it like a castle. And we're going to put on firewalls and moats and build tall walls and do medieval whatever. The challenge with securing things like a castle is cost, is expense, is that it slows things down. All the reasons why DevOps doesn't talk about security, doesn't talk to security, is the same reasons that we then come and go, we will build a castle around you. So there's some fundamental ways that you can add security without slowing down, and that is the second part of this talk. Here's what DevOps is, and here's where we're going to add the security without slowing it down. Some of the ways to do that, just fundamental principles, is not building castles, not over-engineering, surveying first and often so you know what you've got to do, leveraging some standards and practices. That sounds boring, but we'll get into that. Defending from a position of strength, and then creating some street smarts. So as we walk through this case study, we'll refer back to these principles and I'll show you how these all come into play in action. So DevOps starts with code, right? A developer is writing code. And they're checking that code into a source repository. Some version control system, could be Git, could be Subversion. They're checking code in. The thing I think we all know as security professionals, but I also think the thing that developers always forget, is it only takes one line of code. One line of code, that increases your attack surface. One line of code gets you into a situation where you could have a vulnerability. If you look at things like NIMDA, right? There's only one line of code that was a flaw in there. Heartbleed, one line of code that caused that vulnerability. So we need to put some controls in the beginning. Those controls typically are things like design review, code review, doing pair programming, sitting down, getting your folks together. You want someone who's going to be angry at code vulnerabilities. You want someone who's going to be infuriated by defects, someone who's going to be a champion for clean code. You want to find your Hulk, right? This is the guy who's going to be like, Hulk smash, fix your code. And you need this guy, but you also need the guy who's going to be like, hey, I'm Doug, right? It's all good. We're going to lead a revolution if you want to come. If not, it's okay. You need your Hulks, you need your Dougs. And you need someone who's like, will be the Hulk you wish to see in the world, because that's the guy who's going to be pushing really hard. But then you need the Doug who's, after the Hulk beat him up, will put his arm around him and go, it's okay, buddy. We'll do better next time. Here, just write this one line of code. Just do this one thing. How do you find your Hulks and Dougs? One of the ways to do that is lunch and learns. A cool practice for lunch and learns that I've seen recently is scheduling 2 hours. So you got your 101 content, put on the calendar for regular users, 1 hour, right? Come see the 101 stuff that you need to know. Here's how to write clean code, here's how to write, avoid exploitation, here's what SQL injection looks like, cross-site scripting is a thing, crypto mining is a thing. Come for 1 hour. So you schedule that for 1 hour, but on your calendar, schedule for 2 hours. People come in, they hang out, you talk through the material. Anyone ever do lunch and learns recently? Most people like sit back like this or check their phone the whole time. But there's always that 1 or 2 guys who are like, what was that? You can do that? There's a cross-site, people are using crypto mining the browser? And like, yes, they are. And you want to find those guys, right? Those are usually your Dougs or your Hulks. You don't know which yet because you haven't made them mad. But if you schedule for 2 hours, you got to make them a little mad. If you schedule for 2 hours, after that hour break, they're going to come up. And they're going to be like, hey, what was that thing you're telling me about? And that's when you're like, hey, you know what? I'm glad you asked. I don't usually show what I'm about to show to anyone but the elite. But for you, Doug or Hulk, I will show this. And you have your 200 level material ready and canned and slotted, and you write those names down because those are the people who are going to become your champions. And then you build that relationship with them over and over, and you maintain it over the longer term with that program. Really cool way just to use a standard lunch and learn, but extend it and tweak it a little bit and offer something of value for people who really care. So, first thing about securing without slowing principles is building that street smarts, is creating those security champions for code reviews. And doing so in a way that when they're going through and they're looking at the code and they're doing these things and having these conversations, you're using that as a way to drive behavior, right? You're enabling the Hulks, you're enabling the Dougs to say, when you see this, have this conversation, and oh, by the way, if you need more information, here's a wiki page, here's good code examples, here's whatever you need. Next thing we got to do is, of course, make sure that they're using good code. I'm sure everyone's heard about Equifax by now, something about social security numbers. I hear credit cards were lost. One of the things that cracked me up when this happened is I really just was like face palming for a week, is how the security people were like, it's because of struts. Apache has this vulnerability called struts. And they're like, if you only didn't use Apache, you won't have struts, and struts is bad. I'm like, oh, come on, guys. By bringing the communities together, of course, we can begin to peel that onion back and say, okay, what really happened here? It was not necessarily just because they had struts. At first, does anyone not know what struts is? Let me start there. Everyone's like, I totally know what struts is. Awesome, good. So with the MVC that they were using and building their code on with struts that had this vulnerability, the vulnerability was in Jakarta. The Jakarta vulnerability was simply in how it was processing uploads. So when they're doing an upload process, there was an error handling issue that if the file didn't get parsed correctly, it would get passed on instead of throwing an exception. It would get passed on, the exception would bubble up, and that would cause a process overflow to happen. If the code in if Apache was running as root or as a privileged user, now you got high-level code running as a privileged user. When it comes back to Equifax, that's exactly what ended up happening. The exploit hits, code bubbles up, now you're running as a privileged user, now you can get shell. Equifax, you guys hear how many times they actually got popped? They found something like 47 shells. 47 shells. And then when they were actually doing the forensics, some of it was great because they had like command line, right, what people were executing. They had one guy who just logged in, he's like, who am I? And it went, root. He's like, ah, and the guy never connects again. And I had this image of this guy just running Metasploit somewhere going, oh my God. Out of the room, not gonna let anyone notice. But yeah, tons of people attacked them because this vulnerability was in the code. And it was just that one line of code that allowed the bad guys in. So we've gotta have the ability to do design review and code review, where we got folks who are looking for vulnerabilities and folks who can say, hey, yeah, don't do that or do this. Another thing interesting about that is using something like static analysis, which will go ahead and scan the code for you and point these vulnerabilities out, find lots of vulnerabilities, get them back to the developers, and let them do what they need to do about it. When doing this, knowing those champions, you had lunch and learn with them, you had some relationships with them over a few weeks, 6 months later, you're doing SaaS, and you notice a problem keep happening and happening and happening. Within sitting duck shipping, they noticed that every single time they brought the pen testers out, the pen testers found that there was this exploit and SQL injection that allowed them to take over the database connection. They'd do the pen test, the developers go, okay, fine, we'll fix it. New app would come out, pen testers would come back, they'd find the same thing again and again and again. Finally, they stopped and said, okay, why do we keep having this problem again and again and again? And they peeled it back and started having conversations. They brought all the developers in the room, and they put up the code, and they said, this is the problem that we're having. What causes this? And Doug went, oh, I know that code. And they're like, okay, great. Yeah, that's in our wiki. What? The vulnerable code was in their internal Confluence page that was, oh, you're creating a new application? Here's how you connect to the database. Every new application was instantiated. The developers would go to the Confluence page. They copy that code. Doug's like, yeah, I helped write that. I'm like, great. Thanks, Doug. So what we do there is conduct shipping, the security team comes in, they work with the code, they get the right pattern and practice on the Confluence page, so now when people are copying it in, they're secure by default. And that's when you can have Hulk, right? Because then Hulk sees like, Hulk smash, use Confluence, and then we're in a good spot. Got to have your Dougs and Hulks. All right, so then we can do the scans. Now, one of the things that I found very interesting was with SaaS tools, they take a long time. So I was working with one organization, and they're like, we are moving to 4 releases a day. I'm like, that's fantastic. That's a great deal of velocity. When I was doing DevOps back at a financial services firm, we thought we were really cool when we got like weekly releases. We're like, yeah, we're awesome. Like 4 times a day, that's BA. He's like, yeah, it is. And I go, how are you doing that? And he goes, well, by skipping the code scans. Oh. Why? Well, the code scan as set up by the security team took 72 hours to complete. So they would do one release, send it off for 72 hours, and then just go, and end of the week they go, oh, thank you so much, security team, for checking that. We'll get right on this. It was terrible. So another key principle in terms of stop building castles is to make sure the security controls that we're asking the DevOps team to do fits in with their actual pace of doing the work. If they're doing a 4-hour release, we need to give them a scan option where they can go ahead and scan within that window. For this particular example with conduct shipping, what they then do is just scan new code, scan the delta, and then scan the full code base on a periodic basis, such as full release or once a month, something like that, where it can run for a long time. All right, and then another problem with SaaS is always the false positives. Always, always, always. It's a false positive. Whap. No, it's not. Several different mentalities of this. One way to do it is to have the Hulk run that code scanner, smash it, and only give good results to the developers. We will not have false positives because if it gets past the Hulk, we know it's actually something you need to worry about. That's a cool methodology. It does take some time, and you do need a very strong champion for that. Another way of doing that is to say, hey, there are no false positives. We are going to figure out what is intrinsic in the way you're writing code that triggers the sensor, and we're going to create better standards for you so you don't trigger that. Update Confluence, do developer training, and whatnot. That's a different way of doing it, right? I don't know enough to say if this is false positive or not, so we're just going to assume that it is an actual result, and we're going to help you develop around it. That's another way. There's a couple different ways to handle that. And of course, there's the mid-ground, which is you just pick the high priority ones, and you tackle those, and you have a whole backlog of undone things. But the key point here is, when looking at these code results, we want to create a culture of quality and security, right? One line of code at a time. Here's what the scanner found. Let's have a conversation about it. Let's use it as an opportunity to drive culture. Let's use it as a training moment. Let's use it as a teaching moment, and use that code scanner not as a way to say, gotcha, you guys do terrible developing. I knew it, and I'm going to tell the CISO. No, that's a terrible way to do it, right? It's much better to create that as an opportunity to do some learning. So that's on the dev side. Let's talk a little bit about DevOps build. What DevOps build environments look like is developers doing what developers do. They're writing the version control, and you've got an automated system like Jenkins that's pulling that version control and checking it out. And when the code is committed, it builds it and deploys it to an integrated test environment. Pretty cool. Saves a ton of time. This is something that when I used to run dev teams, it would take a good week to stage all this. Now it's automated, and now it can be done automatically. Key point here is, for every line of code we write, there's a ton behind the scenes. If we're writing 1,000 lines of code, there's probably millions that we're supporting, right? If we're writing 500,000 lines of code, which is like a typical CMS or web app, there's probably 50,000 lines of code behind that, just in libraries like struts and the OS and the web server and everything else. Now, there's a thing called defect density, you guys probably know, which is the number of defects per 1,000. So generally it's about 0.69 according to Coverty's most recent report, but that's a few years old. Some teams it's much higher, 2, 3, 4. Some teams it's much lower. Important thing is that you know internally within your own team what your defect density is. So we'll go 0.69. That means on the typical code base of a CMS, you probably have 345 defects and then about 34,000 defects on your OS, your web browser, and everything else. If we say 1 in 20 of those defects are security vulnerabilities, that is a typical number that I've seen in some of the teams I've worked with. Again, some is much higher, some is much lower. Important that you know your own. But if we just use that metric, we can say right away with this code base, so we're probably looking at 17 vulnerabilities in the app layer and a whole bunch in the OS and the web server. Knowing that is absolutely critical. By being able to size the universe and go, okay, based on that, you probably have 17 vulnerabilities if you're starting out. Here's how we get down to it. We can then begin to figure out what kind of controls we need to wrap around and how quickly. The other thing is that we can then begin to say, okay, these are some numbers to track to, use it as KPIs to figure out if our developers are doing good or bad, if our program is working, if we're driving culture, if we're actually making an impact, or if they're just making the same mistake again and again and again, if we're status quo. With these bottom ones, right, without the supporting code, it's very important to track and report on vulnerabilities in third-party libraries. This is a tool called software composition, right? Software composition analysis, things like Sonatype, will go ahead and report on those vulnerabilities and let you know what they are so that you can address the vulnerabilities in the entire code base that your developers have apt-getted into your project or NuGet or whatever they're using. The important point about this is going back to something like struts, the developers are going to be pulling down modules all the time, right? One of the reasons why DevOps works is because open source is a thing, lots of modules are, lots of things we can use. If you guys look at something just as simple as that struts vulnerability, when it first hit, before it was even known as vulnerable, developers are downloading about 80 to 100,000 times a month. Then the vulnerability hits. Then Equifax gets breached. Oh wait, then the vulnerability hits. Then Metasploit has a module, and we all freak out. Look, it's in there. And then that little kid hits Equifax, and everyone else hits Equifax. Chunk of time goes by. Equifax notifies that they're breached. The media freaks out. Right? We got about an 8-month window from there to there. Yeah, about 8 months, 9 months. Every single month, 80 to 100,000 downloads of that vulnerable app. The developers didn't even Equifax happens, everything. They're like, okay, we'll just, why? Why? The reason is because we have tutorials that tell them, hey, app, get this. We have pages on Confluence that are like, when you build your app, use this, right? We have cookbooks and Stack Overflow and everything else. And they're following the same pattern and practice to get their work done because they're just trying to get their work done. We need to give them a better way to get their work done. We also need to have visibility into when they're getting their work done in a way that jeopardizes us, because everyone is. So we start with that software composition, and we go ahead and create it. So in Sitting Duck's case, as SAST is spinning up, and we're not giving them all the vulnerabilities, we're just giving them a couple of things to work on because we don't want to run them into the ground right away. We're going to put in something like Sonatype and start looking at their code base, all their dependencies, all their modules, and start looking for what vulnerabilities they have there, not giving them to everyone, because for every Hulk and every Doug, you have another 100 developers who are like, if those security guys give me one more thing to do, we don't want to do that. So we'll just give them a couple of the high priority ones and start in the background as a security team building our plan to address all the technical debt that they've undoubtedly incurred doing nothing more than doing the job like developers do. So that's the build side. Test. When we get to test, so we got some source code built, Jenkins does what it does, it gets an integrated test environment, there's a UAT environment, and usually a manual test environment pushes out the code, and then it does what it needs to do. A number of different apps to use this, things like JUnit and Karma. For QA testing, oftentimes Groovy, Cucumber, Capybara. What's really cool about these things is that even though these are not necessarily security tools, if you've got a good indication, especially from your SaaS tool, hey, every time this happens, developers introduce a couple different things, this causes a problem. If you've got some good indication of what those are, you can build those into your automated scripts. You can build them in so it checks it and it breaks the build if you so choose. So common security errors, we can break the build and have developers fix, or at least have them aware of them before it goes into a production environment. Pretty cool thing. Then with our traditional security tools like DAST and interactive testing, we can plug them in to hit the QA environment. So what that may look like is, for our hypothetical case study, sitting duck shipping, other developers are doing something, and they're like, oh, we can't do DAST in the traditional environment. We oftentimes hear this, well, because we don't have a full environment. We don't have a full application. We don't necessarily want to run it against our production. That would break things, it would slow things down. What happens if our super important user logs in at the same time your DAST scanner is running? All those sort of things. What's kind of nice about DevOps is much, much more likely to adopt something like DAST, these dynamic scans that log in, crawl through the pages, run user tests, because they're already in that mentality of, oh, when I push it out to my dev QA environment, automatic test runs. Kind of cool. This is one that I see a lot of companies adopting first, because it's more in line with the DevOps mentality. Oh, it's also much quicker too, right? If you're doing hourly and daily, you can run these scans in a much, much quicker way than doing something on a weekly basis or a monthly basis. What this allows us to do is start uniting code quality and code security. Developers traditionally, in my experience, they want to do a good job, right? You want to be the most BA developer ever. You want to be seen as a developer who comes in and is the hero who's built something that no one else could build, whose code is so squeaky clean that's amazing. You want to be the guy who is forever immortalized on that Confluence page. And so if we can go ahead and tie that into what they're doing on the security side, we are in a really good place to win. So if we can unite code with quality, or code security with quality, we can be in a spot where we can really push things forward. One way that I really like is rugged software. When I was doing DevOps teams several years ago in the early days of DevOps, before everything was automated like it is now, I was a big proponent of rugged because it's got just a great manifesto, right? I'm a rugged developer. I'm rugged because my code's rugged. I'm rugged because I understand vulnerabilities and I will not let myself be vulnerable. I'm rugged because it's not easy, but I'm rugged because I'm up to the challenge. It's a great talking point for those Hulks and Dougs to get them motivated and then have them talk to other developers. Because other developers don't care about security, but sure as hell they care about their ego, and sure as hell they care about doing a good quality job. So that's out there, and I like that as a talking point when we get to DAST, because at DAST and those controls just look like another quality check. So it plugs right into the way they're thinking already. Now at that point, you can gate or you can not gate. There's a couple different ways of thinking about this. Control gate is where you stop and say thou shalt not pass, right? We broke the build. We will not let you push to production. The good thing about gating is, as the security guy, you feel good about that. I've stopped the bad. I have prevented the vulnerability. I've saved the world. Your security team may be, or your software development team may be very frustrated with you. You did what? It's a button. Let me push my button. I'm like, yes, but that button might be a false positive, but that button, right? So you can create some natural friction there. But some development teams love that because, hey, it's gated. We're all clear. We all know what we need to do. Another way that I'm seeing a lot of teams move is to not gate, which sounds kind of risky to me. I'm a security guy. I want to control everything, right? But some of the large organizations are adopting a not gate approach where it's okay. You don't need to gate. You're a developer. We trust you. You do what's right. But if you don't gate, the next time we have a stand-up, it's your responsibility to come before all the developers and explain to all those folks why you chose to not gate. Completely trust you. You rock. You know your code. But just let the rest of the team know in a public forum why you chose to push a vulnerability to production. Cool? Cool. That also seems to work very, very well. There's an organization that does taxes. I'm not going to name which one, but I actually switched from, she was great. I had this little accountant, little old lady. She had like the little manual typewriter where you click and the paper roll would spin, if you guys remember that. And she did my taxes by pencil, and I just loved her to death. About 2 years ago, I actually did my taxes online for the first time ever, begrudgingly. But in part, it was because I was talking to the DevOps folks and DevOps conferences are those companies, and they don't gate. They're like, but we don't get vulnerabilities. I'm like, how do you not get vulnerabilities? I'm like, because the developers have to stand up, say, I allowed this to pass. Peer pressure says they start correcting each other's errors. Like, that's fantastic. And talking with them, I actually built up enough trust to let go of my little old lady who used to do my taxes, was wonderful, and move to an online system because I truly believe that they've got it really well buttoned down. So I'm seeing both sides, and I'm seeing both ways play out. Sitting duck shipping, we'll say they're not going to gate for the sake of the case study, and they're going to use that cultural lever. It's really more, though, of a more mature program, I believe. You've got to have people at least at level set with the good Dougs and Hulks and all your teams before you can start pushing that, maybe a year in. All right, so the next thing on the DevOps side is packaging and releasing. So we've done the integration test. Up here, we were scanning the code, then we built it. Now we did some integration testing, we ran some DAS tests, and we did composition tests, and our acceptance environment ran, and manual people did manual things, and now we're going to push it on into production. And we're going to say, okay, any defects you have, you choose whether or not to pass them. We're not going to gate it. What's interesting here is that, like so many security controls, so many times when we put in technology, when we get to this point, we've reduced a lot of the ways that criminals would ordinarily mess with developers, right? Hopefully they got clean code. Hopefully we've avoided the ability for someone to sneak code in with peer review and manual review, right? We're not going to have the office space with the high-fiving and passing discs around and everything and stealing pennies on the dollar. We've got a lot of those controls done. And we're using the CI/CD to pipe it all through. At which point in time, the CI/CD itself becomes something that's incredibly vital to protect. That continuous integration, continuous deployment, that pipeline, we've got to wrap some controls around. Because it's that level of automation means that the people are not in control of that entire space, good, but also means that they oftentimes don't notice when things go wrong with that space. Have you guys seen MEDoc, which was compromised with Discoder, or CC Cleaner? You've obviously seen what I mean. With CC Cleaner, what they think happened was that they got into the CI/CD pipeline, bundled that Trojan in to that build process. When it built and got pushed up to production, then everyone was downloading for about a month, I think? About a month that they were downloading this vulnerable version. And surprise, it came with its very own Trojan. You get a bonus. Now, they know it wasn't within the code base because when they reran it and pushed out subsequent versions, the subsequent versions didn't have the Trojan. It's just that small window where they were able to inject that code into the CI/CD and push out the vulnerable image. Unlike MEDoc, the Discoder, where they actually did get into the code base and injected that vulnerable code there, and it was built and released, so you had a much longer window of vulnerable code with this malware inside of it. Kind of cool attack, right? We rely very heavily on our automation, but our automation then becomes a very interesting attack vector for criminals trying to break in. So we got to make sure we're protecting that. All right, then we can get to the release and the pen tests, right? Everyone wants the pen tests. But as an aside, pen tests are an interesting thing. So SingDuck has built their app. It's in production. We don't really build a pen test out. I was looking back at the history of pen tests. When I ask a lot of folks this, it really depends on if they're my age or like millennials. Ask a millennial, when was your first pen test? When was the first time a pen test was done where they're trying to, demonstrate risk and show that you could break in? It's like 2000. I'm like, close. As someone my age, like 1995 when Hacker movie came out. I'm like, close. 1967. 1967, I want to take you back for just a minute. The Beatles were on, which was fantastic. All you need is love, right? It was the summer of love. Cars looked like that. So if I was doing a YouTube video, I'm not sure I'd mount my camera, but probably be a huge thing that would sit right there. Cars looked like that. Computers looked like that. And the RAND Corporation brought together folks into a conference, much like Circle City, a little bit bigger. It was 15,000 people. And they dared to ask the question in 1967, could computers and communication lines get broken into? I think we all know the answer. But it was the first time anyone actually asked that question. So in that year, they got together some budget, they did what they needed to do, and in 1972, they did the first pen test. A guy named James P. Anderson. I love that name, James P. Anderson. It makes me think of like the Matrix. Like, hello, Mr. Anderson. I'm like, you are fantastic. He is the OG of pen testing. I tried to find a picture of him because I wanted to actually like show the picture of him, and I finally did. But then it was like, best guess, senior citizen. I'm like, that is mean. You leave that old guy alone. He's a hero of mine. He published, and you can take a look at this, attack scenarios and his results. And up until the point where you start hearing about like punch cards, because the adversary could like learn your source code by looking at punch cards, it sounds a lot like what we do, right? The operators of the system recognize a potential vulnerability, leveraging unrestricted programming. I'm like, yeah, that could be written by my red team yesterday. So we've been doing the same type of pen testing from 72 to 2017. We go in, we demonstrate the risk, we identify it, and we're like, hey, look what we broke. Give us money to fix it. Long, long time. Back when Nixon was around. And politicians were like Nixon, which is nothing like today. Okay, I'm not, forget that part. Especially if the NSA is watching. But my point is that when we do this type of testing, we have to go beyond just demonstrating we can break in. We have to look at the controls that they actually have in place. What have we built in the system to protect the system, and can we validate those controls? You say you got 2FA, can we get around 2FA? Right? First, does 2FA exist? Is it really in place? This sounds really simple, but I do a lot of security assessments, and Zach's shaking his head because he does them with me, and the customer's like, we totally have a awesome Wi-Fi that's guest access only and is segmented, and you can't, you're like, oh, the one with clear text password that I just got to your manufacturing line? That one, right? So does the control exist? Is 2FA actually been implemented, or did the developers just say, yeah, it totally is, boss, so they could get off a red list? Next, is it effective, right? Is it just a gate in the middle of nowhere, or does it actually work? Back to the 2FA example with Sitting Duck Shipping on their app, can you connect to the API and bypass 2FA? That never happens. Microsoft Office 365 2 years ago. Can you pass a token and bypass it, right? Is 2FA really working? Is it effective? If it is effective, can it be circumvented? So 2FA works, that's fantastic, but is there other ways we can get at the source data? Your 2FA is fantastic, but you've got a database over here, and all your data is on S3, and by the way, your S3 is public and read-write to the world. This is the control actually doing what it's supposed to do. This, by the way, is one of our guys. We do a lot of physical security, and this is really BA. It's a badge cloner. So imagine your badges are up here. He'd walk up and go, hey, how's it going? You doing all right? Yeah? You have any plans for the weekend? All right. Good talking with you. And then he'll go to the door and be like, yeah, all James Bond-like. It's fantastic. So can it be circumvented? And finally, is it operationalized? Meaning, as these controls are being poked at and prodded in a pen test, is it jingling bells and getting people's attention? Does security operations know what to do? If it was a real attack and suddenly there's a whole bunch of HTTP 500 errors, maybe that should be looked at. Or does no one notice at all, right? So is it operationalized? 4 ways of pen testing above what we've been doing for the past 20-odd years. So we can never really attest to security, which is something we always want to do. We want to say this is a secure state. But what we can do is we can attest to a strong set of detective and preventive controls that we worked with Doug and Hulk and the rest of the dev team to build in the Sitting Ducks application. All right, now back to DevOps, configuring and monitoring. You guys probably hear all the time about infrastructure as a code. I really like infrastructure as a code. I love the concept. When we get to that point, we want to do more than just look at the code itself. We want to look at the full infrastructure when it's in production. Part of that is doing interactive testing, where it's going ahead, logging the pages, running the use cases, making sure things are working, making sure there's no new vulnerabilities. Oftentimes, in mature programs, we'll have code that was clean, we'll have great use cases, it passed the pen test, it's in production, we shouldn't find anything, but someone finds a vulnerability, right? Struts now is vulnerable, and we catch it at this layer using interactive testing and your standard vulnerability management, right? Your Qualyses, your Nexposes, Nessus, what have you. So we want to run it against the production environment every single time period, every single night, every single week, not letting it go more than a week, because once that vulnerability comes out, we all know HT Moore's law, which says as soon as Metasploit has a module for it, everyone and their brother is going to be running it. So we want to make sure we detect it. So the point here is that we all know the criminal and the curious are constantly scanning the internet for targets of opportunity. This has been known for a long time. It's been proven in a lot of different ways. One of my favorite ways was when SANS connected a Windows XP computer to the internet in 2004. It was compromised in 20 minutes again and again. Felt really bad for that little XP guy. Like, poor guy. Today it'd probably be much faster because XP could probably blow on it and break into it. But they redid this test. I don't know if you guys saw this. Last year they redid it with a DVR. They connected it to the internet. And the DVR, the IoT devices, 2 minutes tops. It's crazy. So I call this the Age of Ultron rule. You guys seen Ultron, I hope? Most of you have? It's a great robot, right? Tony Stark spent a lot of money developing it, a lot of intellectual property. He probably did the pen test at some point in time. It's a really good device, full buy-in for the dev team. And then they connected to the internet, and like Ultron went crazy in about 2 minutes and tried to take over the world. Age of Ultron rule. So we don't want to let our apps go the way of Ultron. So important that we're constantly scanning like the bad guys, looking for the vulnerabilities, and tracking and reporting on any exploitable action. Now there's still going to be weird stuff that comes out, right? Spectre and whatnot. That's going to change everything. I was actually interviewed, and the guy's like, "Is everything terrible?" I'm like, "No, it's another unpatched vulnerability. Like, we still got people doing MSOA at 6.7. Trust me, they're going to break that first." So we still want to know what those vulnerabilities are and get ahead of them. But on things that come out that we can't fix right away, we want to make sure that we're finding other solutions, right? So when Struts was vulnerable, a lot of organizations couldn't patch it right away. It took a very long time to get ahead of it because developers basically had to rewrite their entire code stack onto the new version of Struts. Why is that important? Why that's important is we as security have the ability to secure without slowing down by adding things like a WAF to add some level of protection ahead of that, right? To soft patch to give our developers some time. It's not perfect, but a WAF, of course, will allow you to stop some of the targets and cut down on the scanning, unless they actually are going after just you. Right? If they're going after just you, there's WAF bypasses, and everyone can look into that. But that constant scanning, the Age of Ultron problem, we can stop with a WAF. Now, the other thing that WAF allows us to do is to monitor user behavior, know which ways the apps are used and misused. I've seen really good security developer partnerships where security is looking at going, here's what I see going on, why are users doing this, this is strange, and they're feeding that back to the dev team. Devs going, oh, that's really cool, that's a different use of the application. We expected them to do this, right? The William Gibson rule about technology, the street finds its own use for technology, happens. Oh, okay, thank you for that. We'll add a new feature, we'll correct that, we'll put in better guidance. So you do have the ability to feed back and give some really cool intel to the developers. And that WAF can give us some good protection. Now, looking at time to see how much I want to jump ahead here. Please bear with me while I jump slides. One of the things that's interesting about infrastructure as a code is it begins to actually become a security feature. A lot of times organizations with static dev teams can't move readily to a new version of the OS. They can't move readily to a new version of the PATS infrastructure. They can't just try Struts and see if it works and fall back if it doesn't. And so the ability for them to do that with something like, oh, we're just going to spin up a new environment, throw the app over there. If it doesn't work, fine, we'll fall back, is a really cool feature that with DevOps and security we can then take advantage of and adopt patches in a much faster way. It also allows us to start codifying some rules and helping them build within an automation stack to make sure they do the right thing over and over. The spinning out of S3 bucket, teach them how, and with the automation, enforce how to spin it up in a secure way. critical because Gartner's showing that by 2020, 95% of all the cloud security failures will be the customer's fault. It's a lot. But it only makes sense because we constantly shoot ourselves in the foot because we don't use these automated tools, right? We do everything manually, we follow the cookbook, it's very easy to make mistakes. By using infrastructure as a code and embedding our security controls in there, we can hopefully avoid being Verizon, Viacom, Accenture, or anyone else who's had an S3 bucket problem recently. And implementing standards such as a CCM or CSC in that infrastructure code as they spin up new environments, they can get more hardened over time, and if it doesn't work, we can fail it back and do what we need to do. We can also then leverage a lot of the patterns and practices that the providers are putting out. Azure, AWS, man, I spend a lot of time with their resources. They got a stellar security team. Azure's doing some great stuff too, but they've got, hey, here's how you build a good system. That's awesome. Now you put that in the automated build, spin it up, push your app out there. It doesn't work, no problem. We fail back immediately because we're DevOps, we're nimble like that. So fundamentally, DevOps and infrastructure as a code becomes a security feature, which can be incredibly handy for us. All right, so then we iterate and automate. We keep doing these pipelines. We keep doing them over and over, and we embed the security controls in place. And we hopefully do so in a way that doesn't necessarily melt the dev team or the organization. One of the key things here is human psychology, right? People can only ingest so much change at a time. So as we're doing these tools, we're planning out the roadmap, we've got to make sure we've got capacity in there that we're not asking the DevOps team to take on more than they can handle. DevOps folks are actually really good at this because they got tight timelines. We're releasing every 4 hours, great. They can tell you how much work they can do in 4 hours. We've sat down with good DevOps teams and said, hey, look, here's what we want to do. We want to phase in these security controls. And they're like, awesome. 3.5 weeks from now. I'm like, what? That's when we'll do it. How do you know that? Well, because we've got this dip, and then there's this, and then there's a quarterly report, and our stories, and 3.5 weeks. That is phenomenal. You go to a normal dev team, you're like, can we do this? I'm like, no, absolutely not. Never going to happen. Our boss won't let us. You know what I mean? Because they don't know how to estimate it. They don't know how to take that on. So automating the controls is a really strong control for that. And allows us to put things in place that can go a lot quicker. And sometimes even go so quicker that by being in a secure state is actually more advantageous than not. At RSA this year, I was at the DevOps Day conference, and one of the speakers was talking about how in the federal government they created a FedRAMP DevOps kit. You want to do DevOps? Great. You can do it the normal way, and it will take us 6 weeks to validate your code and 6 months to certify your infrastructure. Or you can adopt our kit, and you can do it now. And the kit had all the controls in place, everything locked down, all automated. You better believe people were all over that thing. They were jumping on and adopting that secure way because it was a quicker way to market. And one of the few examples I've seen where not only did security not slow things down, within the federal government it actually sped things up. So, in conclusion, if you find yourself with DevOps, don't panic. There are some really great things you can do. And this is usually where I get called in. The other area where I get called in, which can be kind of frustrating for me, is they're like, we're doing all the security stuff. Great. What about the DevOps team? That's out of scope. Us, what, like a couple weeks ago? Don't worry about that. Well, what about vulnerability? Don't. But aren't they doing psst? Okay, it's out of scope. Why? Why? Because fundamentally, security people or developers and operations folks are concerned that we're going to come in and try and build a castle. If you haven't seen this, this is Harlech Castle. It's considered by many as like the archetype of a very strong castle system. Some key stats about Harlech Castle. When it was built, it took 10% of the kingdom's revenue, and it took 3 decades to build. By contrast, a good security team has 0.02% of revenue, maybe max, right? And we're being tasked to change things in a couple hours. We can't use this castle metaphor. And so oftentimes security used to be known as the team of no, but like, oh, I'm no longer the team of no, I'm a modern CISO. I want you to slow down and think. And at the same time, the DevOps people are like, have you seen the speed we're trying to hit? We are not slowing down. So where castles were manual and not standardized and took years and years and not agile, we need to get a better way of building security programs and doing them in such a way that are flexible and fast. Another principle I mentioned today was serving the land often, focusing on knowledge and visibility, looking for defects in the code, looking for the components that we use that may be defective, and bringing that visibility back to the DevOps team so they can act on it. We talked about standards and practices, using the standards from AWS and Amazon, from the Center of Internet Security, from the Cloud Security Alliance, and building those in an automated way so that it becomes a repeatable process. The developers click a button. It doesn't add any time to their day. That's really key. We talked about starting with a position of strength. When we go ahead and pen test, not only finding the quickest way in to pen test and flipping over the table, which Red Team loves to do, and we will continue to do for probably another 25 years, but also asserting a defensive core and validating those core holds up, that we have the controls, that they're working, that no one's turned off 2FA or whatever it may be. And then creating a culture of street smarts, using the pen test, the static analysis, the defects we find, the modules they're using as a moment in time to step back, have a conversation, engage the Hulks and the Dougs, and create centers of excellence within our DevOps teams and drive it from a cultural perspective. Because when we're driving from a cultural perspective, that's really when work gets done, right? When work looks like work, work gets done, and when work and security and quality come together, developers want to do it because they want to be the best of the best, and they want to do it in a quick and easy way. We can help enable them to do that. And that's how to secure without slowing. I want to thank you guys for coming out here this morning.